Okay, hopefully I interpreted this expression correctly. This is some function, very complicated looking. We're supposed to find the equation of the tangent line where x equals 1. And eventually we'll have to find out what the y value is when x equals 1. I've done that right here. Looks like 7/4 e, or 7e over 4. But to find the derivative of y using logarithmic differentiation, we're taking the natural log of both sides, and we're exploding this expression, which consists of products and quotients, into separate terms using the properties of logarithms. So in the numerator, the log of a product equals the sum of the logs, and I can also move these exponents down front. So this x to the 5th, if I take the log of that, is 5 ln of x, plus ln of e to the x, plus ln of 4x plus 3, and then minus the factors in the denominator. So minus ln of 5 to the ln of x, minus, I move this 2 down front, property of logarithms, there it is, minus 2 times ln of 3 minus x. And simplifying this just a little bit, 5 ln of x, ln of e to the x is just x. Ln of 4x plus 3 stays the same. Here I can move this ln of x down front using properties of logarithms. So I'll have ln of x times ln of 5. I use the commutative property of multiplication to change the order there, so it's easier to see what happens when I take the derivative. And this last term stays the same. Now we're ready to take the derivative. The derivative of ln of y with respect to x is 1 over y times y prime, the derivative of the inside. And term by term, we're going to take the derivative. 5 times the derivative of ln of x is 1 over x. The derivative of x is 1. The derivative of ln of 4x plus 3 is 1 over 4x plus 3 times the derivative of the inside, which is 4. That's where this 4 came from. The derivative of this term, this minus ln of 5, that's just like, that's a numerical coefficient. So I take that times the derivative of ln of x, which is 1 over x. And minus 2 times the derivative of ln of 3 minus x is 1 over 3 minus x times the derivative of the inside, which would be minus 1. That's why this minus became a plus right here, because I had minus 2 times minus 1 is plus 2. And finally, y prime is equal to this mess right here times y. If I wanted to recopy all of this over here, I could have done that. Now, to find the equation of the tangent line, we need to, first of all, find the y coordinate of the function when y equals 1, or when x equals 1. We just put 1 in wherever there's an x, and there's what it simplifies to. To find y prime, I'm putting 1 in wherever there's an x in this expression for the derivative. Okay, and we get 5 plus 1 plus 4/7 minus ln of 5 plus 2 over 2 times, remember that value of y sitting out to the right. If we add all these, collect similar terms, I should say, we get 53/7 plus minus ln of 5 over 70 times 70 over 4. And then we use point slope. So y minus y sub 1 equals the slope times x minus x sub 1. And that translates into y minus 70 over 4 equals, all of this is the slope when x equals 1 times x minus 1. That's the equation of the tangent line. Pretty messy. Here's a picture from Desmos showing the graph of f of x, that's this red curve, and there's the tangent line at the point 1, and that's 70 over 4 right there. Okay, there you go. Hope that helped. If you have any questions, post a comment.